So what we're actually going to do is kind of talk about NGRX, but you don't want to dive into NGRX without understanding what the actual the package and the module is actually built upon. So that's the idea here, and it's a bit of a tough one for early in the morning with little coffee. So this is what we're essentially trying to achieve today. So has anyone used Redux before? Just plain Redux? And keep your hands up if you've written plain Redux, like your own custom store. So a couple of people. So we're going to be writing a store today. It's going to be kind of a little bit similar to NGRX, and then what we're going to do is actually compare it to NGRX at the end, so we kind of get an understanding of the first principles and then what NGRX store looks like. So, why should we focus on Redux? I think it's, we all like new tools, we like diving into new technology quite quickly, and I know for one that you pick up a new tool, oh, have you used this lately? No, I haven't, I need to jump straight in and start using it. And you might not sort of understand or look at the principles that XYZ package was built for. So this is kind of the idea for this talk. There's not too many slides, and then we're going to kind of just live code piece by piece a custom store and explain and then look at the NGRX side. So this is the goal. Understand NGRX, understand Redux, then NGRX. So Redux, NGRX, this is the flow of what we're trying to achieve. Now, for those who haven't heard or used NGRX store, the store is essentially a Redux implementation with observables, and we use it for Angular. It's kind of came out of nowhere when Angular was released, and it's become probably the de facto what we should use or what we can use. The library's progressing very quickly. There's lots of new changes. They just released version 4, and I think next year is probably going to be a very big year for NGRX. So I want to kind of set this up. We're near the end of the year. We could do some Christmas reading and start fresh next year. So here's the official Redux logo. Just like to throw that in there for give the team some credits. So we've got a couple of slides. What we're going to look at are the 3 principles, which, there we go. So these are kind of the 3 things that we want to think about with Redux. We don't want to just dive straight into NGRX store. There's other packages. NGRX is DB. We've got the effects. We've got entity, which has just been released. So we need to kind of, before you dive into any of these, try and think about the pattern that they're actually implementing. We don't just kind of create random modules that exist for no reason. There is a structure and a pattern behind them. So we need to kind of look at the 3 principles behind NGRX store and in fact, the Redux principles. So number 1, we have the single source of truth. Sounds more fancy than it is. Source of truth sounds monolithic and responsible. We also have state as read-only, the read-only state. We'll come on to this in more detail. And pure functions, in fact, update the state. So let's look at number 1. A couple of things to note. These are kind of some benefits and some features. So what do we get from the single source of truth? We get one state tree. So the idea with using a store is, like, who's used Angular 1? Who's came from an Angular 1 background? And so we had this mystical $scope object, which we just bind everything to. State management kind of wasn't that great back then. We had lots of stuff living in components, and maybe a service, and the communication between the two. You had like watcher problems, for example. So the idea is that we completely abstract the state away from the actual application into a single store. Now this has benefits because we can have, let's assume, 2 or 3 components, and each of them can ask for different pieces of the store. It also means that different components can dispatch information, and they don't have to pass it up a particular chain. So the idea of a one state tree inside of the store is we just have this store object, and it's just a mystical object that we can inject into a component, we can inject into another component, And we can say, give me this piece of state, give me this piece of state. Now, some of the benefits, it's easy to maintain, and we use this word predictability. So from a maintenance perspective, you may be writing what seems like a lot of boilerplate, but in the end, using something like Redux has a lot of benefits. Now, universal's an interesting one, which is, I've put SSR for server-side rendering. So at the moment, the Angular universal is kind of being worked on. I think next year's universal is going to be really, really exciting to work with. But for now, what we'll just do is talk about the actual universal and how you can, or what the benefit of using a store is. So let's imagine for a moment we have our application. Imagine the last app you've built or the app you're currently building. How are you managing state? You might have a service when you've got an array or a subject or a behavior subject, and you're injecting it into multiple components. Now, if you imagine you server-side rendered this approach, you're going to have kind of a lot of trouble trying to make all those different requests before you go ahead and render your application. Now, if we use a store, we just have one state tree, which means we have one JavaScript, plain JavaScript object. So when it comes to universal, we can actually, on the server, just create this state tree ahead of time, and we can just render that state tree. That means that on the client, our state for a particular page, a particular view, is completely ready. So we can just pass it straight into the store, and the whole component tree will then populate. So this is the idea behind it, and I think we'll see a lot more of this as well. Testing and debugging, things like the Redux DevTools, these are really powerful. If you've used the Redux DevTools, we do things like timeline debugging, time travel debugging, where you can essentially see changes to any state that you make. So you can use a timeline, you can scrub back a few states, you can see the differences between the two. So that's principle number one. There's a lot to kind of think about of all these practices that we should be doing, and you go on Stack Overflow and you think, oh, I'm doing it wrong. So hopefully we try and follow these as a guideline. So state is read-only. This is also a really important, and it's also interesting because this is where we sort of introduce immutability. Now I know when I started back with AngularJS or Angular 1, the immutable, thinking immutably just didn't exist. We would just mutate everything, digest cycles, explode on us, these kind of things. So the idea with state is read-only is we just have this one state tree, and we can ask for pieces of the state tree. Now, we only ask for the pieces of the state tree. Once we've, for example, have a piece, we could have a list, a collection, for example. We don't want to mutate that in any way, shape, or form. Now, if we want to actually change the state tree, this is where point number 2 comes in. So we dispatch actions to change the state. So if I want to add a new item to a collection, I can dispatch, add this item to my collection, and this is where the store will then handle these processes for you. And this comes down to immutable update patterns. So once we actually want to make a change, we want to think immutably, not mutably. We don't want to be mutating things. Objects, arrays, functions, these type of things in JavaScript are passed by reference, which if you've ever tried to update an array and you've got a reference to it somewhere else, these things update in multiple places, which can lead to difficult to debug bugs that are difficult to debug. That was a hard one. Number 3 is pure functions update the state. So at the moment, we've kind of got this idea that we've got a state tree that's going to somehow represent our application. If we want to update it, we can, what we call a dispatch, an action. So we can say, go and update my state tree. Now, what the store will actually do is take that action and pass it to our pure function, which is number 3 here. And in this case, this is where we update the state, and this is where we need to think immutably. So let's have a look. So pure functions, these are called reducers. They're called reducers in Redux. They're called reducers in NGRX store as well. Now the interesting thing, when we dispatch an action, it could be, for example, add to do. We can respond to this action type. So we can say, do I want to add a to do? You could just do an if statement, or we use a switch statement is kind of the convention. Now, the third, but not least, reducers, they return the new state. So the role of a reducer is to be given the state and the action, and we can compose the new state of what the representation will look like after we've made this change. It could be something as simple as adding an item to an array. But once we've done this, we need to do it in an immutable way, so we don't want to get given the state and start mutating the state, because that will cause bad side effects. So what we need to do is think immutably. We can use immutable operations. I'd love to do a whole talk on it, but we would be here for like 3 days, I think, if on immutable stuff. But once we've made an immutable operation, we then want to return that new state from the reducer. Once our reducer has returned the new state, this then gets bound to the state tree. Everything's updated. The store, which is one of the characteristics of a state management library, will actually go and notify the subscribers. So if you've used Redux, you can use the .subscribe. If you've used NGRX store, we have the store.select. Now, you may have read the documentation as well. So store.select returns an observable. So anytime we change the state tree, the observable is just going to emit new data to us. So we just automatically subscribe. And that's where things like the async pipe with Angular come into play. So core concepts. This is where, hopefully, I haven't had any coffee yet, and we're going to do the rest of it is live coding, so I hope this goes well. So we're going to touch on the core concepts, and we're basically going to build out these things. So we're going to build single state tree. We're going to talk about actions and action creators. We're going to talk about reducers. We're going to build a reducer, and we're going to build the store, which manages the whole thing. So I've got one-way data flow at the bottom, and all I'm going to show you is how these kind of pieces fit together. So let's assume that we have a component, and this store, it's not an object of, it's just the green dotted line that we have here. So the store kind of encapsulates, it manages these things that we want it to. So let's assume that our component has some data in it which we've asked from the store, but we want to actually change that data. So to change the data, we need to dispatch an action. We need to say, here you go, store, go and actually do something with this new piece of data. Here's what I want you to do. It's an event that basically describes what we're trying to do. Now, the role of the store at this point is to actually take the action and say, okay, pure function, which is just a reducer. Here's the current state, the representation of the data structure, and here is the action that you've just called, or that you've just dispatched. So in the reducer, we get the current state or the previous state, whichever you want to call it, and we also get the action. So this is where the magic happens with the store. This is where we update the state tree, and we return a new representation of the state. So this is what we return to the store. The store says, thank you very much. I will take the new state. I'll update all of my internal state. Once that's done, we could use this NGRX as an example here. So let's assume that we're subscribing with store.select, which is how you ask for properties on the state. That returns an observable. So as soon as this new state is fired, so let's assume we go new state, that automatically gets pushed via an observable back to the component. If you're using something like, we'll do this.to-do list equals store select all of my to-dos, something like that. If you use that with the async pipe, this is just automatically subscribing, automatically pushes new data into the DOM. So that's it for this piece. That's pretty much my whole talk. So no, we're not done. We're not done. I think there was a clap. So what we're going to do, I've never done something as silly idea at this at 9 in the morning. Hopefully we can see this okay. Perfect. So what we're going to do is essentially talk through these pieces. I've got a plain TypeScript application, little small code base, we'll walk through it. But what we're going to demonstrate is building this store here. Then we're going to look at the component. We're going to dispatch an action to the store. We're then going to respond to the action. We'll show you what a reducer looks like. Oh, microphone got lost. Then we'll show you what a reducer looks like, and we're also going to show you the inner workings of a store. So the idea here is that you completely know Redux, you completely know how the internal workings work, And you can go home, look at NGRX, for example. We'll do some comparisons at the end, but you can look at NGRX documentation. You can go, oh, yeah, I remember this. I know how this gets past the state. I know how my action is dispatched, for example. So, without any further ado, I have the most beautiful application I've designed to date. So I know people complain about to-do lists, but we're not actually interested in the to-do list. All I want to show you is the store stuff, and all we're going to do is just render some items. So we're not doing any to-do stuff that's actually of much importance. So at the moment, if I quickly, oh man, everything's so small. There we go. So if I do, we do test, and then there we go. So at the moment, all I've got is an input and a button, and when I click the button, we have an event listener, and it gives me the input's value. So inside the actual code for this, hopefully that's big enough. Does that look good at the back? Yep, perfect. So I've got a couple of query selectors just to some DOM nodes. We've got the input, which you can see here. We've also got the button. I've got an unsubscribe, so I can click this and we can unsubscribe. Now, if you're new to observables, for example, this will actually be really handy because we're actually going to set up our own subscribers. So we're going to learn pretty much how an observable works on a basic level. And then we've also got a reference to the to-do list itself, which we'll come on to later. So here's pretty much what we're going to be dealing with to begin with. We've got this button with an add event listener. We've got a click event. If we don't have any value, we're just going to simply return from here. But what I'm interested in actually doing is taking this piece of data and actually doing something with it. So we've got a to-do, for example. We're going to say, I want to create a new to-do. This is the object of what it looks like. So the label is then driven from the input's value. So that input is then our DOM node. And we're just setting this complete to false. And then this is what you saw in the dev tools. So we just console log, and we just log that out. So that's pretty much all we've got. I've got one folder here, which hopefully you can see. Not too important, the sidebar, but it looks pretty. So here's the base of the actual store itself. You could, this is available on GitHub, or you could send me a tweet. For example, I've got my Twitter handle at the end if you want that, or come and find me outside, and I'll show you this if you want to learn from it. But writing this is a really, really good exercise for self-learning. I'm just going to write it for you, I hope. So what we essentially want to do, I like to use the index.ts pattern. So this allows me to essentially import everything up the top. So we have import everything from the store, which points to this store folder. Inside the store folder, I've got actions, index.ts, reducers, and the store. Inside the index, I'm just exporting everything from those files. So we're just pushing things up a level, so we don't have to keep importing things by name. We can just simply reference them. If that doesn't make 100% sense, it will make sense momentarily. So we'll show you that. So, excuse me. So we want to get started with the store. We'll walk through what we've got so far. So we're going to be implementing some subscribers. So this is going to be, I've typed it here, it's going to be a function array. So each time we call .subscribe, similar to an observable, this is what is actually, they're going to contain our subscribers. We've also got the reducers. Now, NGRX store works in the exact same way, has reducers, they look exactly the same. We just get a few different types that NGRX store will provide us that we can actually add to our reducers for some more safety. Now, a reducer is made up of a key, which we can say is a string, and the value of the reducer is just a function. So in a sense, for those who don't know what a reducer or haven't seen one is, let's just say, we'll just call it my reducer, and it's simply just going to be a function like this. So this is basically what we're telling TypeScript a reducer looks like. So it's up to us to pass arguments, state, actions, and so on. And we've also got the state. So I've put key and a string, and we can have absolutely any value. So that means we can nest objects, we can add arrays, data structures, and so forth. So the first thing we want to do is, what I'll do is create the constructor. Now, you can design a store however you like. You can do it however you like. How I'm going to do it is pass in the reducers as the first argument. Now, I'm going to say, if we don't have any reducers, we're going to supply a default value of an empty object. So when we call internal workings, when we actually boot up and create a new instance of the store, this isn't going to throw us any errors. We also want to pass some initial state, which we're also going to say is just going to be an empty object. So at this point, what we can say is this.state. Now we could say it's an empty object, but we're actually going to bind it to the initial state. Now, when we talk about stores and states, I think it's one of the confusing topics is, should I use a state or should I use a store? So these types of questions I've seen on Stack Overflow and Twitter. So you can think of a store as just a manager of the state. And it gives you a few functions that you can, for instance, call like a dispatch, which will tell the store to actually go and update the state. So the store is just a container, it's a predictable state container, what we call it on Redux, where we can actually manage this property here. So this is what we're interested in managing. Everything is about this.state. So let's go ahead and we'll bind, not like that, we'll bind any initial state that we provide when we instantiate the store, we'll bind it immediately to the inner of the store. So immediately we've got an empty object. So what I'm going to do in here, because I've got import everything from the store, I'll just give you a quick example. So if I do from store and then dot, so I've got a few things which I've exported and set up already, but what we're interested in is the store here. So what we can do, we'll do const store equals new from store. There we go. So this is essentially creating a new instance of our class that we've just created. Now, the first argument, if you remember, was some reducers, and the second argument was some initial state. Now, we don't have any reducers yet, so I'm just going to leave that as an empty object, and we do want to supply an initial state object. Now, what we want to do to get this working is supply a list of to-dos, this data structure, and one of the benefits of using a store and a data structure is how you create these state trees, how you manage them is completely up to you. There is no definition where you have to stick to a particular pattern. The only thing you need to do is be able to serialize this data. It needs to be plain JavaScript. So don't put functions and these types of things into the store. So what we're going to do is say to-dos, and we're just going to give this a label. And if anyone follows me on Twitter, you know I'm obsessed with pizza. So at this point, I use has anyone used Prettier here? We need more hands. So Prettier, I don't know if you saw that, I'll do it. This is a quick thing. So when I press save, that just completely reformats my whole code for me. It might look a bit weird, but as soon as you get used to it, I would highly recommend you install this. For working in teams, pairs, however big, it's good for code consistency. Everyone's code looks the same. And it adds the semicolons for people who don't add them. So we have, at the moment, we've supplied an initial value to our store. We're going to say, this is what our initial data structure looks like. So what I'm going to do underneath here, we can say get the value, return this.state. So what this will actually do, when we reference store.value, this will actually give us return, it will return this.state. So underneath here, we can say console log this store.value. There we go. I'll add a quick, just so we know it's this one. There you go. So we've created a new instance of the store. We've passed it an initial state value. Typically, you won't pass it an initial state value when you create the store, but you may supply quite a lot of initial state in a reducer, for example. So here we've got the data structure that we basically created. So that's now bound to the store. We've accessed it via this .state. So the next piece, okay, so now we've got something in the DOM, in the JavaScript model, for example. When we add a new to-do, we need to actually tell the store to go and add this to our data structure. So what we can do is store.dispatch, and we want to dispatch an action. Now, actions can come in various forms. You can use like an arrow function or a wrapper function. You can use a plain object, like we'll do now. Or you can use what we call an action creator with TypeScript. So, an action has two properties. The first action type, the first property is the action type. So in this case, and you may have seen this looking at some documentation, but we're going to dispatch an event that describes what we're trying to do. We're trying to add a to-do. Now, what we want to do, which is an optional property, so payload is completely optional. However, you probably want to use it most of the time. When you're loading things, for example, you might have load to-dos. You don't need to supply a payload. So we can say the payload is going to be the value of to-do. And what I can do just for ease is just rename that to just payload, single value. That, for anyone who hasn't seen this, is the equivalent to this. So what we're essentially writing is, okay, so when our button is clicked, we want to dispatch that event to the store. So let's go ahead and write some dispatch. So our dispatch function is essentially just it's a command to the store. It says, go and update this piece of state. So we could, real quick, just have a look at what this looks like in the browser. No, we'll do sleep. There we go. So this is our action that we just logged in the store. In the dispatch, we've got that payload. It's complete false. Label is sleep. And the type, which is the important piece for the reducer, which we'll come on to, is what we need. So what we can do is essentially at this point, we want to update this.state. Dispatch is a command that says, please update the state tree if this action exists somewhere in my code. So we need to essentially give the state a brand new representation. Now, for the moment, what we can do is hard code this. So we can say, we want to merge all of the existing state into the current object. So this is, again, thinking immutably. We don't want to just go this.state.todos equals the new value. That's a mutable operation. Now, if you think we've got lots of subscribers or references, that can lead to bugs. So at the moment, we've got the object on our data structure with a value of to-dos, which is just an array. So inside of here, we could say that the new representation of this data structure is going to be this.state.todos. We can merge that in, and we can also use the action.payload. So we're essentially, at this point, we're hard coding the change. We'll dynamically do this momentarily. So we could do console log this.state, and we'll check it out in the browser. So just to recap, we're doing this.state equals a brand new object. We copy all the state in, and then we just make the change that we actually are expecting, which in this case is add a to-do. We can merge all the existing to-dos into the array using the spread operator, and then we can just add that one on the end. So the action.payload is actually going to contain the whole to-do object. So we can go, we just do test, because it's easy. So there we go. We now have two values in our array. We can do testing. There we go. And you can see that that state value is now updating, it's updating, it's updating. We could just check on these and make sure they work nicely. So there you go. This is what we just input into the store. So the next piece is actually doing this dynamically with a reducer. So reducer is where we would typically handle these changes. And this particular piece here is pretty much what we want to do in the reducer rather than the actual dispatch itself. So let's go to the reducers. So we're actually going to change our data structure ever so slightly here. Instead of actually just having a plain array, it can be good to use objects. So if you've looked at the NGRX store's example application, you'll see something like this. So they will have a loaded and false, and loaded is also false. I can't spell the word false, it seems. And we're going to have the data, which is going to be an array. So what we're actually going to create is this is going to manage our to-dos. It's going to add them, it's going to remove them, etc., etc. Now this data property will contain all of the to-dos. So we're just going to reference .data. You might have done this when you get like a server response back. You do response.data, for example. So the reducer itself is where we handle these manipulations, these mutations that we want the store to actually perform. So instead of this instead of using to-dos, we're going to use this data array. Now a reducer, we mentioned it earlier, it takes a state argument and it also takes an action. Now if you've used Redux or NGRX store, you'd have written this already. So we know what these two are. The purpose of this, we'll find out how it works and how we can pass pieces of state to the reducers. So the most common thing to do, we initialize the state with the initial state above. So I mentioned earlier that a store itself, where we have the initial state supplied here, we don't typically do this. We want to kind of do this in the reducer. So the reducer will get called when the store is initialized, and it will return the initial state that we actually tell it to. Now the action, I'm just going to add a type. We're going to say it's a string, and the payload will be of type any. So this is, you use NGRX store. We look at these things, we get different types, but they pretty much do the same thing. We get some additional type safety with NGRX store as well, so this is a good benefit. So at this point, we can return the state if nothing has happened. So what this return state at the bottom will do, when the reducer is called at runtime, it will just take this initial argument and just return it to the store. So that means the store, when we load things up, has these values in the data structure. So before we go any further, what we'll do is actually register this reducer to kind of understand where we're going with this. So at this point, I'm going to delete all of this. And we'll do const reducers. This probably looks familiar to a few. So the purpose of this reducer here is we're going to manage some of the actions for adding a to-do, removing a to-do. So I'm going to call this the to-dos reducer. Now this to-dos declaration will create a property on the whole state object. So when we do this, we do from store.reducer, we're essentially going to get a value returned when this function is called. So the reducer will get called by the store and return a value. So we actually end up, let's assume that this is our state tree. We end up with something that looks like this. Loaded false, loading false. So we'll end up with something that looks like that. So that's basically what we're creating. Now a reducer's role is responsible, because it's the to-dos reducer, is responsible for just managing these properties. That's all it's in charge of. You can create multiple reducers, you can have reducers that call other reducers. It's completely up to you how you want to structure these. So that's essentially what we are creating by actually doing this. So let's take the reducers, and we want to, where we had that empty object to begin with, we're now going to pass in the reducers as the first argument. We have no initial state. We now just want to focus on purely the reducer. So inside of here, we're going to say this.reducers now equals the reducers that we just passed in. So we're now taking that first argument, binding it into the store. So what we want to do is essentially call the reducer when we actually dispatch. So we need to iterate and go and find it. So what I'm going to do is create a reduce function. Thank you, TypeScript. And we'll do private reduce. Now, this is where things kind of click for us when you go, yeah, I finally get where the state comes from and the action comes from. So what we pass into the reduce function is, in fact, the whole state tree. And we also pass the action. So we dispatch the action here, and we're just simply binding the result of calling reduce to the state. And we do that by passing it the actual state and the action. Things can happen behind the scenes. New state is then returned. So inside the reduce, we get the state, and we also get the action. Now, if you may have gone, oh yeah, I kind of see where that's happening. So here we've got state and action, and in the reducer, we've also got state and action. So these two kind of matching up already. So because this is red underlined, it's going to say it's not assignable. We're not actually returning anything. And what we need to return is a new representation of the state. So we can say const, not that, new state equals an object, and we want to return the new state. So it's up to us now, inside this reduce function, to actually go and call our reducers, give them the state, pass the action. So what we can do is we can do const prop in this dot reducers. There we go. So we're essentially iterating over the reducers object. And just to recap, that is this one here. So all we're doing is a simple for loop. To look up the key, we're going to call the function. That's all that's happening. So what we want to do, what we'll do first actually is just look at how to actually call the reducer itself. So that is invoking a reducer dynamically. So it could be, in fact, that in an application, we might have tons of reducers. This is how we loop over them and can actually reduce them to a single value. So we've only got one in our case, but you could add multiple reducers, and this would actually work straight out of the box. So a reducer, as we know, so we have the state, and we also have the action. So how do we actually pass this through? So it looks like private reduce actually gives us the things we need. So we can say we're going to pass the state, and we're going to pass the action. Now, I mentioned a moment ago that this to-dos object, where we had this, I'll just rewind, there we go, where we had this data structure here, the reducer is in charge of just managing these properties. So we need to just select those properties from the store and pass them to the store itself. That's not right. There we go. So how we do that is we state at this point in time is going to be the whole state tree. We don't want the whole state tree. We want, not that, state, come on, there we go. So we want state.prop. Now prop is going to be to do. So essentially, if you look at this, we have this dot reducers dot to-dos. We're then calling that as a function. Then we're passing in state.todos, which is the slice of state that the reducer manages. And then we're going to say, here is the action as well. So then we can respond to the action. Now, at the moment, we're not actually doing anything, and we're not binding it to this new state object. So we need to say that the new state, square bracket, prop, equals the result of. So this is, in fact, going to create a new data structure. It will be state with a to-dos property, and those properties have now changed because we have called the reducer with our new action passed in the state. So this is the kind of flow of events. So let's go ahead and actually test this out a little bit. We can say under here, log this.state. Cool. Now we'll just we'll do the good old hi. That's what we like as developers. Let's do test. There we go. So we have to-dos. And my data is empty because we don't actually have a function in the reducer. So at this point in time, we've now called the reducer. We've passed it the state, passed it the action. So what we need to do is then switch it. So we can say switch action.type, bang. So inside of here, we are now responsible for a switch case. Now, a switch case actually looks up this action.type. So we can take this string, we can say, give me the add to do, case of add to do. So when the action.type is then, we just pass the action to the reducer. When the actual type is add to do, we want to start thinking a little bit immutably. So we want to return a brand new object, and this is how we get that new state representation. So because we get given the state, we want to merge all of the current state in, but we also want a reference to the to-do, so that's going to be bound to the action.payload. We can then say const to-dos equals a new array. We want to spread the state, oh no, we want state or data, not to-dos. And then the new to-do at the end. So we've got the data which holds the array. We've got a new data array which merges the old data array, passes the new one in. So we can simply, at this point, just add this to the return statement. So this is an updated collection. So now, hopefully when we go back, we could do hi. 1, 2, 3, 4. There we go. And we now have our completely dynamic reducer that's now updated the entire state tree. So we're managing different slices of state. You can see that this one's called the to-dos state, and inside it is the data. We can use it in an application like a loading spinner, if it's loading, if it's loaded. So you might get some ideas from that, as we mentioned. So the next piece, after we actually dispatch, at the moment we haven't really rendered anything in the DOM. So let's finish this off. We'll go and say that we want some subscribers now. So we can create an array of subscribers. Where are we? There we go. We're going to call a subscribe function. What we'll do is just quickly set this up inside of here. So when we store and subscribe, we want to get given that whole state tree. So at the moment, we don't actually have anything that gives us this state tree. So it's red because we haven't actually finished it yet. So we're going to just log out the state, see what it gives us. So the subscribe function takes a function, red's gone. We can add this to our array of subscribers. Now this is how kind of an observable would work. When you subscribe multiple times, it will give you those values. Now we can also use some immutable patterns for adding that list of subscribers. So we start off with an empty array. When we subscribe again, we want to merge the existing subscribers and just pass that in at the end. So what we can do under here, when we subscribe, we want to return an unsubscribe as well. So we could do this.subscribers equals this.subscribers.filter. We get each subscriber, and we can say that the subscriber does not equal the current function that we just passed in. So we're just checking if a function equals a function, basically. Now, when we subscribe, we actually want to pass this.value, which is this one here, which will in turn give that subscriber the state. So let's have a look. We're doing console log, and we could do state, which is an empty object, yay. This.value, I think we need to call reduce. There we go. So I forgot to call reduce on initial state. So when the store is instantiated, we need to reduce the initial state. So any reducers will get called and return any of these initial properties that we have here. So when we look at this, we have the state tree. Nothing's inside it just yet. We can do test, add that particular item, and the state hasn't been logged. Oh no. Dispatch, there we go. So when we dispatch an action, is the next piece, we need to update the subscribers. So we can say this.subscribers, we can iterate over each subscriber, and we can say here is the value. So this should be the trick. There we go. So we've got the initial state, add, there we go. We've got one item in the array, which is our data, which says test. Cool, so we are almost ready to render the to-dos. Now, our data structure, as I mentioned, it was state, .todos, and then we have that data array. So we do .todos, .data, and we can save this out. So I'll close this off. We can do eat pizza, sleep, and we've successfully created a Redux store end-to-end, which is kind of observable-ish in a way. It's not true observables, but we've got some kind of subscribers in there as well. So that's pretty much it, end-to-end. That is how you can build and think about reducers, actions. We understand all the moving pieces. If you want to catch me afterwards, feel free to come and grab me. I think we're pretty much done in terms of time. So hopefully you enjoyed that, and I really enjoyed that, and thankfully it didn't go wrong. So thank you very much.